Welcome back, everyone, to the eCoreAcademy e-learning platform. Today, my name is AJay back with yet another anatomy and physiology video within our anatomy and physiology course here at either the website or the YouTube channel itself that's directed you here. And before we get into our new system that we're going to be going over, specifically, of course, the muscular system and some of its basic features and things that we're going to get into in depth through our sequences of videos that I'm going to be adding into this anatomy and physiology course. Please make sure to like and subscribe down below. Also, smash that post notification bell so you don't miss out on any of our channel's latest uploads. Staying in tune with the sequence of videos. The reason why we've organized these videos in sequences of systems, you don't necessarily need to pay attention to the sequences of systems, but the sequences of videos within those systems are very important to go through it. If you're not entirely aware of what exactly you want from these videos, please make sure to go through these sequence of videos in the order that is given, so that we can initiate the system in the best possible manner, so that you're not confused and you have to go back and double check things, reconfigure certain topics that you might not have been sure of, that may be covered in later sequences of videos within that given system. But without further ado, and also don't forget to drop a comment down below, and of course share our video using the YouTube icon or through our website there. Please share our links and utilize our website as well. I'll get into that at the end of the video, of course, if you forgot. But just to introduce our new system, this is the muscular system, a very famous system. I actually recently learned the muscular system for last year, or about 2 years ago. I did a science Olympiad competition. That's when I learned the integumentary and muscular system, as well as the skeletal system. So this is something that's very fresh in my mind, and I hope that can really help you guys. I had a bit of a struggle learning muscular system because a lot of information gave different quotes, different quoted information. I got a lot of this information from the Science Olympiad website that helped me determine what type of notes need to go in, and using my preparation of my notes and tools, try and find out the best possible way for you guys, the learners, you guys as learners, to really, or refreshing, trying to refresh yourself, to really learn and refresh yourselves on these topics in the easiest, most efficient way possible. So, what is the whole entire theme of this overview? What is the muscular system is essentially what we're looking at, and how exactly does the separate counterparts work together. So the separate counterparts would be the anatomy part. We're looking at these separate parts, like such as the whole body. That's like looking specifically at the organs. But in this case, we're going to be looking at separate muscles, and within those muscles, those biological roles. And then, of course, we're going to be looking at the counterparts in which they all work together and initiate movement. That's going to be the physiology part of this lesson. We're always going to incorporate both because it's very important to understand the roles and implementations of anatomy within physiology. So without further ado, let's get right into it. Let's give a bit of a formal introduction on what the muscular system is. Now, a lot of times you're given information on a lot of new topics that you learn about, but you don't necessarily know the essence of the topic. You know what the topic consists of, but you don't know the essence. When you think of muscular system, you can obviously think of all the muscles within the body. What you think of, gains, what you go into the gym to actually build up. Well, of course, we already have pre-existing muscles. All you're doing is, when you're working out, you're tearing up your muscle fibers. You're literally damaging your muscle so that when recovery happens, your muscles know how to adapt to the situation, and oftentimes they promote growth with the proper nutrition, protein, all those things come into fact and play, and I'll talk about that in our later videos. But just as a brief overview, looking at the biological definition of the muscular system and, of course, its specific counterparts. So muscular system overview as a formal slide title. The muscular system is a physiological system, of course, in anatomy and physiology, that encompasses all of the muscles within the body. There are actually 650 muscles within the body and only 206 bones. So you can tell how many more, muscular movements that these skeletal muscles actually provide for the skeleton and for the body itself, and how minute and definitive these muscles can be. When someone talks about, you have to work your muscles out, and they talk about, get big biceps, a lot of people think of it like quadriceps, your quads, your hamstrings. People think of those muscles as one muscle, but that's a muscle group. There's so many minor muscles within there that make up that muscle. That's why a lot of times you'll hear minor and major and Alice at the end of these muscle groups to determine what the relation is within that muscle group itself. So there's 650 muscles in the body, give or take 640 to 650, and how they work together helps generate movement upon the skeleton. And of course, the skeleton itself is very flexible, much more flexible than you think. It has a lot of spongy bone within it. It only breaks when there's a lot of pressure and maximum contortion, but that's really how your muscular system muscles really bend that skeleton in order to provide movement for the body. So the muscular system itself does not produce movement, but it can initiate through the skeletal system by flexing and extending its muscles. So when you're utilizing your muscles, there's some very important laws that we have to follow, which I'll introduce in the next slide. But essentially, your muscular system is bending your skeletal muscles using that spongy bone to actually bend those bones. And also they help support your joints, help cushion your joints, and help generate the movement. They initiate movement, but they do not create movement. The skeletal system creates that movement. And lastly, of course, it protects the body's joints and bones by helping, cushioning them, taking off some of the force and providing some of the force to go against something. Likewise, so if you're thinking of a common situation when you're, say, for example, you're in football, like American football, and you're a offensive tackle, and you're trying to, ram into their defensive line. Essentially, what's going to happen is if you're not going hard enough at the other player and you're just standing there or you're walking into them, you're going to get hurt. The other player is going to come out completely fine. That's because you have to be able to give enough force, and that muscular system helps provide enough of force in order to make sure that you protect your body. So if you go into things hard, you're not going to get hurt. So this is, a common example. People think, oh, you got to work out your arms or just your biceps. Well, the biceps themselves, they literally show two major muscles within the biceps, and then you have other tendons and ligaments and minor muscles located along that help support that contraction. So you have your contraction and extension. So if you're looking at my bicep right here, essentially it's going to contract when I, bring it inwards, and it's going to extend when I bring it outwards. So when it's extending, the muscle's relaxing. When I bring it in, the muscle's contracting. And likewise with your quadriceps, oftentimes misconceptualized. There are many layers of muscles, actually, different types of muscles that consist of your quadriceps. And you cannot just merely call a quadricep a muscle, it's a muscle group. Now on to just muscles, properties of muscles. So how do muscles work? So muscles produce force and movement by either extending or flexing, like I said, in which the muscle will squeeze its muscle fibers in a contracted manner. So when you're squeezing inwards, bringing your arm towards your shoulder and really flexing that bicep, what's happening is those muscle fibers that are spread about are going to come much more compact up in the center, and they're going to start to spiral upwards more. And that's because basically your muscle fibers are becoming way more compact. And when you relax, the muscle itself actually extends outwards, it stretches outwards. That's why when you're stretching, you're actually just extending, meaning you're keeping your joints straight rather than bent in which you engage the muscle. And this time you're stretching that muscle, in which the muscle fibers will actually stretch out and remain in a relaxed, natural state. And when it comes to motion, muscles only pull and do not push. And this is very important. So they're initiated by tendons and smaller muscles. That's where the actual pulling happens. Oftentimes we think of, your push and pull. When you're going into the gym, this is very basic. You have your pushing exercises like a push-up, say for example, you're pushing yourself off of the ground. And oftentimes we think that the muscle itself is providing that pushing force. However, it's all a pull. So when you're pushing, essentially, this tendon right here, it's going to be a part connected to your pectoralis major. That's actually going to contract, and it's going to cause a pull. So essentially what's happening is it's causing a pull, which is causing that extension upwards. And when you're coming down, that pull is going to just merely decrease. There's no push, only pull. And a muscle's range of motion is determined by the joint at which it supports. So say, for example, if you're at the shoulder joint, your deltoids, your rear and frontal deltoids are going to be much more, have much more range of motion than, say, for example, the edge of your quadriceps, what really supports the knee, and, of course, that patellar tendon right below that knee as well. They have less motion in those areas. Like I said, the deltoids, and then and also another example would be the jawbones near the temple. There's not much movement. It's only downwards and upwards, and only located for the lower jaw. So it's very distal from that muscle. So just two common examples, three actually, with the quadricep. Now let's look at some basic functions. I don't want to get too in depth, but I do want to introduce this to you. I will get in depth. The axon and myosin will probably be our next video in this system. I'm debating between two videos to make that follow this one. but most likely will be actin and myosin, the basis of muscles. Part one, I'll go through this fairly quickly so that you guys aren't confused, but just get a general idea. So actin is a actin is a specific type of protein found in muscle fibers that is made up of thin filaments and acts as the motor for muscle movement. So the actin itself is that protein. It's kind of like your amino acid builds up that protein, just as it would any protein, and it's a very thin filament. So that means lots of things can really pass through it, and it's very small itself, and it acts as the motor for the muscle movement, really providing that energy and ATP connecting you to it. And then the myosin is another thick filament in the muscle fibers that has strong bonds with actin. And essentially, what happens is these two groups, you could call them groups, but necessarily they are filament proteins. When they are bound to connect, and proteins and chemicals such as tropomyosin, which I'll explain later, they kind of get in the way. So these two proteins are essentially attracting towards each other, specifically the myosin binding sites right located on those muscle fibers, and those actin proteins that are free floating. When they're trying to attract towards each other and they're trying to bind at that site, tropomyosin and other chemicals, when you want to flex, they will get in the way, and then the muscle is actually forced to contract in that manner. And I'll explain how that works, how the fluid balance in the muscle works as well. Actin and myosin part two, I'll just show you how that looks here. So that's your actual attached to your muscle fiber. It's actually attached to a sarcomere, which is a section of your muscle fiber, but don't worry about that. I'll explain exactly what all of those terms are. And then you have those chemicals that get in the way of that actin, really connecting to those myosin binding sites, as you can see. And when that happens, that forces a contraction. However, this contraction a lot of times is voluntary, unless, of course, it's your involuntary muscles. But these are major muscles, so you're going to have a lot more of this contraction in your voluntary muscles. Now on to antagonistic pairs, part one. This is very important and something that really needs to be shown through. So these are some basic principles that I really want to show you to establish a base and really eliminate all further confusion. So antagonistic pairs, what's one way to sum it up? It's all about synchronized movement in an opposite manner. So contrary to popular belief, muscles that work in opposing directions in force, meaning completely opposite. I don't mean assisting muscles that you might use in the same workout, you might feel the same pump for. It's opposite muscles working in the complete opposite direction with a complete opposite force. They will always work together in one movement directly. So they're always directly or indirectly related. In this case, they are directly related. So, for example, if you are doing a push-up, I'll explain that in the next one, but I'll save that. But some antagonistic pairs that we're thinking about could be your chest and, of course, your lateralis, your back. So your back, it's a pulling motion, and when you're using your chest, you're pushing something away, essentially. And I know that the muscle cannot push, obviously, but it's in relation to the body. An object will be pushed away, such as a barbell when you're doing a bench press, or a pull-up when you're pulling yourself up. So essentially what's happening is both muscles will be working together. However, one will be considered the major muscle in that aspect. So if you're doing a push-up or a bench press, that your chest is working. However, your back is going to be used to control your chest so that it doesn't overextend, go all the way through, and just keeps it in a controlled, steady manner without any twitches or shaking. And muscles work in antagonistic pairs, which means that muscles that produce equal and opposite force will always work together in order to control the movement of the working muscles. So essentially, you are working your back when you're doing a bench press, but it's not in the way that you think. It's just to control your chest, essentially. You're not really going to feel that much of a workout in your back if you're doing a bench press, but you will feel that supportive consistency developed. And this helps in protecting joints from dislocation and muscles from overextension, as I had previously said. So now let's take a look at a diagram. This is an interesting point that I thought was made when I was doing my research. So this is a common example. So we have Bob over here. Let's call him Bob. And Bob is a very, very fit person. And obviously he's demonstrating a push-up for us. So what's happening here? What's the major muscle in this group? Well, of course we have the triceps, but you also mainly have your pectoralis major. So that's basically your pecs, your chest. That's one of the major muscles used in this group. However, what would be that minor supportive muscle? Well, that would be your lats. That would be his back. So what's happening is you can see his back is actually clenching together. That's to control the movement of his shoulder blades and the actual chest expansion, so that he keeps the chest properly from straining, getting a muscle cramp, or even dislocating his shoulders, his maybe a rib, and even sliding his shoulder blades out too much. So that a lat is really helping him control the movement of his pectoralis major. So that lateralis is very latissimus is latimus dorsi. I apologize, not your lateralis. Your latimus dorsi is really helping him. And just to really finish things off, we're going to go through two more slides on oxygen and fermentation. So this is all about aerobic respiration. So how do I bring this into light? Well, when you think about your muscles and you're doing such exercise, such as, Bob there doing a push-up, essentially what's happening is you're going to keep doing your push-ups, right? Until you start feeling a really bad burn and until your muscles just cannot work anymore. That's complete exhaustion. Well, how are your muscles powered in that same way? How are they constantly powered? They're powered through oxygen, through aerobic respiration. So when oxygen comes through and it enters the body, this is something that you learned in biology. So if you are confused, please make sure to visit Anita's videos for Biology 1, and you'll get a full explanation on this. But just to recap, of course, when oxygen enters, it helps that respiration process, and it helps you harvest that energy, that glucose, and then helps release that carbon dioxide and that releasing process lets the muscle continue to work. But after a certain amount of time, your body will not be able to utilize the oxygen because you went to physical exhaustion. And that's exactly what you want to do in order to promote muscle growth. And when you do that, there's no longer enough oxygen. You're not getting enough oxygen to really help that muscle work. Then it will go to anaerobic respiration, which is called fermentation. And it develops something called lactic acid. But don't worry, I'll get into all of this in later video, just introducing these topics. So aerobic respiration is when the muscle utilizes oxygen in order to conduct its respiration, and utilize glucose to power the muscle when the muscle is, of course, relaxed, or at least it's in an engaged manner, but you're able to do it without any pain and obviously in a relaxed motion, something that you're comfortable with. And oxygen starts this process with glucose and allows for carbon dioxide to be respired. So let's take a look at that equation just to recap. So you have oxygen here, and then you have glucose here, C6H12O6. So when O2 and C6H12O6, this should be 6. I apologize. 6O2 plus C6H12O6. That's actually going to equal your water, H2O, and your carbon dioxide, CO2. This is going to be 6 each. 6H2O and 6 CO2. So essentially what's happening is you're harvesting your energy here using oxygen and sugar, glucose, to harvest that energy for the muscle to continue to work. It makes your ATP energy, which is necessary for all movement, force, and survival for any living organism. And then essentially what's happening here is you have to get rid of this water and this carbon dioxide in order to continue this process, specifically 6. And when you're not able to do that, when you're not able to get enough oxygen, this process cannot be hindered. Otherwise, the muscle will have to stop working. Therefore, you will utilize other methods such as anaerobic respiration, which is when you do not use oxygen or you do not have enough oxygen to provide that respiration. So anaerobic respiration is a process in which the muscle does not have enough oxygen to power its muscle contractions. So therefore, it uses fermentation instead of oxygen. And this type of fermentation is called lactic acid fermentation, where lactic acid builds up as a byproduct. So when this happened, your lactic fermentation really helps ferment the energy that's utilized through other energy molecules that are substituting the oxygen and glucose. There'll also be other ATP-like molecules that will produce ATP, and some of these examples are FADH2, NADH, and pyruvate. And as simple as that, these molecules do produce your ATP energy in a different manner, and that's all in your biology unit, but I will go over this a little bit more in depth, specifically for the muscles and like striations, all that sweet stuff. So these guys all produce ATP. And that's why oftentimes when you have a really good workout and you're completely exhausted after that, you might not feel it. You might feel like a pump, a lot of blood flow, but the next day you're going to feel extremely sore and your muscles are going to ache. that's really the lactic acid built up. That lactic acid is not necessarily good for your muscles, but the lactic acid fermentation is good. That's a bad byproduct, essentially. So lactic acid is not good, but it does signal soreness, which means you did work your muscles out in a good manner. Just make sure that you don't overwork yourself. Do something productive. Make sure you don't hurt yourself and your muscles and your muscle bellies. Give your muscles time and do everything with proper form and controlled manner when you're lifting and dealing with heavier weights. All right, everyone, so that'll be it for today's video. This has been the eCoreAcademy e-learning platform. Please make sure to like and subscribe down below, and of course, hit that post notification bell so you don't miss out on any of our channel's latest uploads. Please check out our website at www.ecoreacademy.org. Link will be in the description down below. See what kind of videos we have out there, because we have full unlocked access to what we as an online e-learning platform actually offer. We have note sheets, quizzes, worksheets that our managers have been developing for that website, and of course, us ourselves. We've developed those notes and integrated quizzes to really help you with those courses, and we've organized them in a productive manner. Also, feel free to email us at eCoreAcademy@gmail.com if you have any questions, or if you just want to reach out to us for any future opportunities or just questions in general on certain topics. Also, feel free to utilize that comment section, please. And check out all of our socials at Facebook, Twitter, and Instagram. See what kind of interesting content we have out there, and please use those mediums to share all of our videos. Once again, everyone, I hope you guys enjoyed this video. This has been AJay Raj, and I'll see you guys in the next one. Peace.